My name is Eva, and we are going to talk about the poster developmental and individual differences in coupling between sleep spindles and slow oscillations. First of all, sleep spindles are bursts of neural activity in a specific frequency range. And sleep spindles can occur at the same time with slow oscillations. Then they are called coupled spindles. And coupled spindles were found to be especially beneficial to sleep-dependent memory consolidation and related to cognitive abilities. Age-related changes in coupling are understudied both in the typically developing population, but also in the population of children with neurodevelopmental disorders. In this study, we pulled together 3 data sets that were collected in the University of York. That brings our sample size to 84 individuals, children, typically developing children, and 40 children with a neurodevelopmental disorder, 23 with dyslexia and 17 with autism. The groups did not differ in terms of age or nonverbal intelligence. We first of all looked at the amount of spindles and specifically how this amount changes with age. So the measure here is spindle density, that is the number of spindles per minute. And what we see is that both for coupled spindles and for the total spindle density, coupled and uncoupled, there is a significant increase with age in the typically developing group. However, this is not the case for the neuroatypical group, where, as you can see, the line is quite flat. So there is no significant change with age. However, the groups do not differ in terms of the total amounts. So there is a difference in the dynamics with age, but not in total counts, both for the coupled spindle density and the total spindle density. Then we looked at coupling consistency. So each line here denotes a single event of a coupling between a sleep spindle and a slow oscillation. And the slow oscillation positive peak is denoted as 0. Then the spindle peak can be in 0 as well, or it can be anywhere else on the slow oscillation. For example, shortly after the positive peak around here, 30 degrees. And we see 2 examples. For this participant, the different coupling events are quite widespread. So there is no consistency in terms of where will the spindle appear on the slow oscillation. However, for this example, the events are more concentrated here, and so there are more events in which the spindle appears after the positive peak of the slow oscillation and quite close to it, so around 0 or around 30 degrees. Thus, the coupling consistency actually tells us how similar are the different coupling events for one individual. And we see an increase with age in coupling consistency, both for the typically developing as well as the neuroatypical children. So while we did not see an increase with age in spindle density for the neuroatypical children, we do see an increase in coupling consistency. To briefly summarize, we saw that coupled spindle density increases with age in typically developing children, but not in the neurotypical children. However, coupling consistency increases in both. And this points to the coupling mechanism as a potential marker for persistent learning difficulties. We think that future longitudinal studies will reveal more about that. Thank you for listening.